Okay, let's dive right into this. Welcome back, everyone. Today, we're unpacking something that is, quite frankly, a total game changer for building web applications. I mean, if you've ever found yourself pulling your hair out over chaotic, untyped React apps, the kind where data structures just randomly shift and bugs only decide to pop up at runtime, well, you know the exact pain point we're fixing today. In this explainer, we're looking at a highly structured roadmap for integrating TypeScript with React. It's essentially a construction blueprint. We're going to take this from absolute ground zero all the way up to the penthouse of complex, globally managed application states.
So here's our agenda for the build. First, we'll lay down Phase 1, the type safety foundation. Then we move on to Phase 2, typing local components. And finally, Phase 3, scaling to global state. All right, so this right here is the exact architecture pulled straight from our source material. This 8-step roadmap, it represents a literal dependency chain. And the sequence we're looking at is absolutely critical. It starts right at the root with TypeScript basics, and then branches out into interfaces and types. Once you've got those primitives established, the tree grows into specifically React territory, right? Generic components, typed props, and typed state. And finally, it reaches the highest branches, typed contexts, and typed redux. So this isn't just a basic table of contents. It's the actual dependency chain of a well-architected application. You literally cannot build the top branches without the roots. This roadmap is going to be our guiding light for the entire build today.
So the crucial point to start with is Phase 1, the type safety foundation.
Our source roadmap explicitly kicks things off with TypeScript basics. Sticking with our skyscraper metaphor, these are your raw construction materials, your steel girders, the concrete, the rivets, the whole shebang. So why does this matter so much? Well, because without an ironclad grasp of the basics, like how to declare a primitive, how compiler checks actually work, how to satisfy the compiler's strictness rules, developers inevitably panic, right? They slap on the any type, and boom, you've completely compromised the building's integrity. I mean, you can't hang drywall if your steel frame is buckling. This step ensures that before we ever even touch a React component, our basic JavaScript is wrapped in the thick layer of absolute predictability.
Now, once we have those raw materials, our roadmap branches into two distinct paths for defining data structures: interfaces and types. These are essentially the foundational blueprints for everything we're about to build. Now, while they often achieve pretty similar goals in modern development, our source specifically separates them into two distinct steps on the syllabus. Interfaces, they generally act as the traditional blueprints for object shapes, capable of being extended and merged as your app grows. Types, on the other hand, provide this incredibly versatile way to create aliases, unions, and intersections. By laying out both interfaces and types side by side right at the beginning of the roadmap, the source dictates that a developer has to understand how to draft flexible, rigorous blueprints before they ever attempt to construct a single room in our skyscraper.
Okay, moving on to Phase 2, typing local components. Now, what's really interesting about this next part is that our abstract foundation is poured, our blueprints are drawn, and so we move on to the physical building blocks of the app. Here, we're seeing the chronological journey of a single component gaining strictness step by step, and the roadmap explicitly lays this out in a very specific order. First up, generic components. These act as reusable, adaptable templates. Instead of hard coding what a component must be, we make it generic, allowing it to adapt while still remaining strictly typed. Second, typed props lock down the component's API, strictly defining the exact data contract allowed in. Literally nothing unexpected gets through. Finally, type state secures the internal memory, guaranteeing the component's lifecycle remains entirely predictable and cannot mutate into some weird shape we haven't accounted for. So it goes component to props to state. It's this brilliant self-contained progression for local security. But this brings us to a pivotal question. Think about it. You've perfectly typed a single component. You've completely secured its API and its internal memory. But what happens when local state just isn't enough? What happens when information from the lobby needs to instantly affect the penthouse on the 50th floor? The walls of our local components are totally secure, sure. But how do we wire the entire skyscraper together without losing that pristine type safety?
Let's move to Phase 3 and see how this builds out, scaling to global state. And this brilliantly illustrates how we solve that global wiring issue. Our syllabus provides two ultimate methods for the plumbing and electricity of our app. First, we have typed context. Built directly into React, this is the native way to pass data deeply through the component tree without dealing with that annoying prop drilling. Applying our previously learned types and interfaces here ensures our native global wiring doesn't short circuit. Alternatively, we have typed redux. This represents an external, heavy-duty library for complex state management. And let me tell you, typing Redux is notoriously strict. It requires typed actions, typed reducers, and typed stores. It really is the ultimate test of everything we learned in the foundation. By placing these two side by side at the very end of the hierarchy, the roadmap shows us that, hey, we have choices for our global architecture, but both demand absolute, rigorous application of the type safety principles we established on day one.
So, we've successfully built from the raw TypeScript basics all the way to the top floor of our global state management. But taking a step back and looking at this complete roadmap, it definitely leaves us with something to ponder about our own code architecture. If typed Redux sits at the very top of this strict hierarchy, representing the most robust, heavy-duty global state validation out there, is your React app truly secure without it? Or is typed context enough to keep your specific skyscraper standing? Take a look at your own blueprints and keep building securely. Thanks for joining me on this explainer.